Welcome back to Lesson 17. This is the first of a two-part series on using vacuum chuck systems on your lathe. So today we're going to talk about the hardware and the components necessary to put a system together. Then we're going to go and examine 4 different setups here in the studio. Each of these are very similar, so we can look for the similarities, but each one has some unique characteristics which we'll point out as we go through them. So I remember when I first was exposed to vacuum chucking and I heard a lecture on it. It seemed very confusing to me, and again when I heard a second one, but third time through I said, I'm going to build a vacuum chuck. And all of a sudden things became a lot more clear. And I tend to use my vacuum chuck almost constantly in the studio at home. And we use them here every time we need to complete a project, maybe finish the bottom of a bowl. So what is vacuum chucking? Well, air pressure in our location, and we are just about sea level here, under standard temperature and pressure is 29.9 inches of mercury, which doesn't mean anything other than a reading on a gauge, but it's 14 pounds per square inch of pressure pushing down on us at all times. What that means is if you ran a 1-inch square column of plastic from seashore all the way up to space and weighed the amount of air inside that column, it would weigh 14.7 pounds. So every square inch pushing down on us, if we're at sea level under perfect conditions, would be 14.7 pounds on every portion of us. Well, what if I was able to set up a system where I reduce the amount of pressure inside so there's more pressure pushing from the outside? That would hold this down. Let me give you an example. On the 6-inch chuck, if I put a bowl on it and I was able to take this pressure to absolutely zero, which is impossible due to leakages in the system and changes in atmospheric pressure, the outside pressure on this would be approximately 415 pounds. I looked down because I had to figure this out in my notes here. 6-inch area times atmospheric pressure per square inch equals over 400 pounds of pressure pushing this into place. If I used a smaller chuck, say a 2-inch diameter chuck, did exactly the same thing. The area included inside of here now is so much smaller that the total pressure is only about 46 pounds of total pressure. So the diameter of the chuck controls how much total pressure. Hope that's helpful. If you go to the website where this video is posted and look right below it on my website, you will find a handout which describes everything I've just talked about and all the hardware I'm just about to talk about. And you can use that for reference in building a system or reviewing some of the notes I've talked about here. Well, how do we set a system up on our lathe? Well, I need several different components. First thing is I need some vacuum chuck, such as this, which screws onto the headstock. In the next lesson, we'll talk about how to build your own custom chucks, similar to these. And that is going to rotate as the lathe turns. And so some connection has to be made through that headstock to a device that connects to some tubing. Here is one way that's done. This piece passes all the way through the headstock and seals right there. This part rotates, and this part down here, which connects to the tubes and onto the hardware, spins free. So I have to have a way of moving air out of the system. I have to have a fitting that will rotate and still be sealed against vacuum loss. That's one way, through the headstock. Another way is over the hand wheel on the outside of the headstock. Similar to this device from One Way. This is their adapter. This fits over the hand wheel or in place of the hand wheel, depending how you set it up. As you can see, it rotates. And all the mechanical hardware here then can be connected to it. So that's a second way There is a third way, but I don't have it here. But up in the upper corner of this, you'll see a picture of this device here. This one fits inside the bore of the headstock. O-rings here seal it. Sealed bearings in this area allow this area here to stay steady while the lathe rotates. It's a third section. Are there other ways? Absolutely. There's a lot of custom design things using shop vacs, vacuum cleaners, and so on. And you can look on the web and find others. But these are the three most well-known means of connecting a vacuum system to your lathe. So what are the components we need? Well, I got this one here. Let's look at it. First of all, we need the adapter. This is what hooks it to the lathe. And coming out of that, I need several other pieces of material. First of all, I want a gauge. I need the gauge because I want to know what pressure, vacuum I should say, what vacuum I'm pulling. I need a bleed valve, a way of adjusting that pressure. For instance, what if I'm turning a very large, thin wall bowl? The total amount of pressure available may exceed what's safe for that bowl. I could crack it. I could actually ruin a product. So I need to be able to bleed off some of the vacuum. And since this is sucking through the product into a pump, I want a filter in line. The ones I've been using are these inexpensive ones. They come in 2 packs. You can buy them at the discount hardware store, or even some of the woodworking dealers carry them. Each, they're about $2 or $3 a piece. So they're the throwaway. And then from that, we go through some hardware into our vacuum pump. The fittings that screw all these things together. It would be good if you used all brass fittings that you got from the hardware store. For instance, this is called a 1/4 inch NPT thread, brass. NPT stands for National Pipe Thread. And unlike the regular threads, this is slightly tapered, which means as we screw it down to the next component, it makes a very snug, firm, airtight fitting. So 1/4 inch NPT brass. What I'd like you not to use is any of these steel fittings. They don't connect as snugly as the brass do. The second thing, from our compressor systems, we use a lot of these quick disconnects. Try not to do that either. They do not make perfect connections. In a vacuum system, we're trying to maximize every little bit we can. So avoid these. As I said, you had to have a valve. This is the kind that I have in my system right here. Closed, fully open, easy to see. 1/4 inch NPT fittings on both ends. I bought this one from one of our discount dealers. I thought it was going to be really fine. And I put it in the system, I checked it. And while it opens and closes very nicely, in the closed position, it still leaks a little bit. I can put my finger over the end and feel the vacuum being sucked. So this is a discard. When I put hoses together, I like to use this hose that has the nylon webbing inbuilt. Couldn't think of the right word. It doesn't collapse. It won't kink. And when I put it together with a fitting on the end, I use these hose barbs like this. I push them into the hose, and then I put a clamp around to hold it even tighter. So this is very, very well secured. You don't have to use 1/4 inch. You can use 3/8, and there are adapters from 3/8 to 1/4. If you go to the hardware store, you'll find all the pieces you need. The list is in the handout of what you would need to put a system together. So I think the best thing to do is for us to put this system actually together. Hook it to the pump on one of our systems. My pump actually is right over here. It's in this wooden box. At home, I've decided to put that in a wooden box just to keep the chips away from it. And since it's enclosed, I'm concerned about heat buildup, so I put a little fan in it. And to make it easy to turn it off and on, I made up a little box with some permanent magnets on the back. It just sticks to the end of my lathe. The second plug here allows me to plug some accessory in, like a sander or something. The bottom is switched to turn my vacuum pump off and on very easily. So this is all the components. We have an adapter, we have valving, We have a gauge, we have a filter, and hose to connect up to a pump. So let's take this over to that old Powermatic behind me and put the system together and show you how it works. I have to find, for this adapter, the correct insert. For that old Powermatic behind me, it doesn't have any threads on the hand wheel, so it takes a special adapter like this, and we'll screw that into here. For my other lathe, the Woodfast I have, it has a threaded hand wheel, and it takes this adapter. So for each of the systems, there may be some customization necessary. For these kind, the correct insert. For this kind, it's important to know the ID of your hand wheel hole, and it varies from lathe to lathe. So when you order this, you simply specify the model of lathe you have, and they'll give you the right piece. So let's step back to that old Powermatic, put all these pieces together, and show how this system actually works. I've moved back to the old Powermatic. I set the vacuum pump up on the counter behind. Generally at home it'd be on the floor. This is that power extension I had. Plug the pump into that. Sits on the end of the lathe on a permanent magnet. So now to install the rest of the system, I have to remove the hand wheel, and that means I loosen these two set screws and pull this off. On this particular lathe, the shaft is straight, and I've installed an adapter in here that slides onto that. There is something to be considered. Now, this is an important thing. This shaft has a slot in it for the set screw to sit in. If I screw this adapter on, that slot is going to proceed all the way through the end, and it's a potential leak. So what I have done is in the base of this, I've dropped an O-ring. So when I slide this on, it's going to seal right to the end of the shaft. So now I'm going to put it in place, slide it on, and I know this is a 4mm screw. Tighten it down. And I think there's just the one. Okay. So that's installed. That's done. Now what I'd like to do is to flip this over here so I can see my gauge. I've got my valve open, filters in place. Now for my own personal convenience, I broke this hose into two pieces. It makes it easier for me to transport. So here's that quarter NPT fitting again. This is a gas fitting, so it fits in here nicely. Screw this together. And to make sure it's nice and tight, take a small crescent wrench. Give it just a little bit of a snug. So the system's together. It's done. So on the other end is going to be a vacuum chuck. And I'm going to step down to the headstock side, and we're going to begin to operate this a little bit and see what a vacuum chuck actually does. So I'm bringing with me two different size vacuum chucks. Both fit this lathe. And I have a little rubber test piece, which I use a lot to see whether or not the system is fully functional. So let's turn it on and see what happens. Right now, no vacuum. We close the valve, seal the spindle, and I'm pulling about 23 inches of mercury. So given the atmospheric pressure and the inefficiency of the system, that is my maximum I can get. And as I open this valve, there's 15, there's 5, and by bleeding this I can adjust the amount of vacuum. So let's put the large chuck on. Seats snugly against the spindle. Hold the bowl on. Now, given the perfection of finish on that bowl and the quality of that chuck, I'm pulling approximately 18 inches of mercury. So that's pretty snug. That's not going anywhere. For me to get it off of there, I have to open the valve. Let's take this one off and put the smaller chuck on. Remember I talked about less square inches, less pressure. Same system. Now because I'm holding vacuum in a smaller area, less surface for it to leak, believe it or not, I actually have 21 inches of mercury, but I only have it over a small area like this, so the total amount of pressure in that bowl is far less. Can I get this off? With a little bit of force I could pull it right off because there is less atmospheric pressure pushing it on. How the system works. And I've always had a test piece because I want to assure what the maximum vacuum is I can pull in this particular system. Where's the leaks in my plumbing? Where's the leaks in my valve? Leaks in my headstock? This tells me I can get about 23 inches of mercury on this particular system. And because the pump releases the vacuum quickly, that piece of rubber would have fallen off of there in about 2 seconds. This is a vane type pump. There's a vane that's rolling around in here, pulling the air through, and it creates a certain amount of noise. There's vibrating diaphragms. There's oil bath pumps. I'm going to show you some of those other options as we go around the studio and take a look at some of the other systems we have installed here. So we're going to go from here to our demonstration lathe, which is a one-way lathe, set up with a very similar system. Now we've identified these components, let's see what a professional system looks like. I think you'll see all the same pieces in the same place. So we're going to move to another location. I'll be back with you in a minute. I've stepped up to our demonstration stage and I want to show you the same system, different components. Here's the vacuum pump mounted permanently to the side. It's a bigger pump than I have, so it's going to pull more vacuum, more CFM, cubic feet per minute. If you have one that has very low CFM and you have a project that leaks a little bit of air, you're going to need to make that up in volume. So bigger pump, same kind of tubing. Here's that inline filter, the valve, gauge, and there's that same adapter. Different insert. In this case, it's one that fits this particular lathe. So now let's turn it on. Here's the power switch, similar to the one I have. Little test piece. Let's see what we're pulling. Almost 28 inches of mercury. That's just about as perfect as we can get in this particular location. This pump is so efficient in terms of CFM volume that with this valve completely open, I still have a little bit of vacuum. Another system. So, professionally installed, higher volume allows me to deal with products that may be more porous or have, let's say, a bark inclusion or some holes in it that need to be compensated for. Let's take a look at two more systems, each one of which is a little custom built, and we're going to go to the other Powermatic we have, and I want to show you another home built system. Different Powermatic, different headstock. This is threaded, so the hand wheel screws on. The person here manufactured a piece of plastic which they screwed to the hand wheel with a foam seal behind it. And there is a double seal rotary bearing that you can get at any machine tool supplier. They're called double sealed bearings. So the plastic on the outside is designed for that just to fit in. The inside rotates. Here is the tubing, vacuum pump, valve. Filters are mounted on the pump in this case. And the valve is a screw type valve in this case. O-rings have been put around this piece of plastic nipple, and a lily can be pushed in like that. Things I would do differently, if I had built this system, I would have not used one of these quick connect vacuum pressure regulators. I would probably put on a larger gauge, so it would have been easier to see. But outside of that, it's a pretty darn good system. Because the way this hand wheel fits on here, I had to take the hand wheel off and put an O-ring on the inside when I screwed it back into place to get a good tight seal. See what it does. Noisy system. This one with my test piece pulls about 16 inches of mercury. So the maximum I can get on this is far less than either of the other two systems. Could I improve that? Yes, I probably could. I would go through and check every single connection. I would have replaced this. Maybe check to see if this valve is good. Let's find that out. How good is that valve? When I put my finger over the valve, it was totally closed. I could feel it being pulled in very slightly, which means that there's some leakage. But when looking at the gauge, I couldn't see the needle move. So the amount of leakage in that valve is very minimal. System works just fine, especially if we have students doing larger bowls, don't need that much vacuum, need large chucks. So let's go to one more lathe, or go to the Jet 16 EBS, which brings up a couple of other interesting issues. We'll step back to that lathe. Here's the last system I want to show you. This takes a diaphragm oil-based pump. This one comes from Harbor Freight. They have available in two sizes, a 2.5 and a 3.5 CFM pump. Operating it, very quiet. It does require pump oil, and it's the same thing as compressor oil. So you buy a quart of this. There's a little sight glass on the end that you can check to see whether it's full up to halfway on the sight glass. Same components: vacuum pump, filter, gauge. You might not be able to see it, but there is a valve right here, open, closed. And the hand wheel here is the original hand wheel that comes with this particular brand of lathe. They always look like this. But the inside has been fitted with another one of those double seal bearings. All we had to do was to take this hand wheel, open it up just enough we could jam one of these bearings in here. And then we simply plug this in, and there's our system. Power on. Plug it together. I've got the valve closed. Test piece. Let's see what we can do. Well, I'll tell you, it looks like we're pulling about 15 inches of mercury, which means that's a pretty doggone good vacuum level. In other words, negative pressure. CFM is only 2.5. It's not as good as those vane pumps in terms of total amount of air it can move at a time. But it does a good job. Now, when we installed this, there was something else we had to check. We plugged everything together, did a test, and had very, very poor vacuum. This has a speed indicator. It has 4 screws around the spindle inside. And those screws go past a sensor, so when this lathe is turned on, we get a reading of RPM. Each of those 4 screws is a potential source of leakage. And when we installed it, one of my students came in and says, I know exactly how to fix this before you even see the problem. He opened this up, pulled each of those screws out, put some Loctite around them, put them back in, and sealed each of those into place. This now has full integrity from one end to the other. So if you have an indicator in your machine that indicates RPM, it may work off of some sort of system similar to the one on this jet, in which case those screws need to be individually sealed into place. Loctite comes in little tiny bottles, drop on it, put the screw back in, everything's fine. So I hope we've exposed you to some options here. Take a look at the handouts. There's a lot of good information there. consider building yourself a system, or you can go to one of the several different sources where you can buy pumps, hardware, even chucks from a single source. There's a couple that are referenced in the handout. Next lesson, when we come back, yeah, we can buy commercial chucks, and I do use some. But I also make a lot of my own vacuum chucks, so they are sized to the projects that I'm working. So next week, what we're going to do is to build a vacuum chuck from ground up. We're going to start with a faceplate and some material and end up with an operating system. So come back for the next lesson and finish the series on vacuum chucking. See you next lesson.